I can start.
So, good morning, participants. So, we are entering into the last day. This is the 11th session. This session is handled by Dr. Lince Matthews, and he is a senior researcher at Amylo BPC product. So, I welcome him to deliver this session. I'm sure his expert knowledge will be beneficial for everyone in uh, in the future. So, welcome, Lince. You can start.
Three is the
Yeah, yeah,
screen
yeah. Screen is visible.
visible? Yeah,
Yeah.
thank you. Good morning, all. I am Dr. Lince Mathew Thomas. Today I'm taking on the topic bioplastic science, technology, and innovation for sustainable future. And in this session, I'm taking on this topic regarding introduction to bioplastics, types of bioplastic, raw materials and feedstock string processes, and the key processing techniques, and the properties and performance are required for a good bioplastic manufacturing unit and applications of bioplastics. And next, the main application of that I'm dealing with is compostable carry bags, and regarding its compounding and formulations, and then to scale up and commercial production and the market overview in India and across India, and the various testing standards like ISO, ASTM standards used for, and various certifications used for the approval of bioplastic products, and for the future outlook. And moving to the first slide, why we are dealing with bioplastics. The reason is the global plastic production has exceeded 400 million tons per year, and it is continues to rise, and over 350 million tons of plastic waste is generated annually worldwide. So I am working in Bangalore, so every day I am seeing these plastic wastes like in a garbage bag. It is just poured on the roadside and across the places. So still, the Indian places or the major cities is still have to identify the proper waste management, and it is 80% okay, and still that 20% is still remaining, and the plastic waste management have to be still is a major thing that India have to look into. And the plastic pollution is now a global environmental and socio-economic crisis. And this slide shows the global production capacities of bioplastics, and it shows the values of the past year, and the expected value up to 29. So we can see on 2029, it is expected to rise to 5,726 in 1,000 tons in the value, and we can see the classifications like bio-based and non-biodegradable, and bio-based and biodegradable. And this slide shows the material development and diversification in the bioplastic industry, and we can see the major polymer, the like I mean bio-based polymer everyone is using is PLA and PBAT, we can see. And majority of the carry back industry is using PLA and PBAT as their main polymer formulation. And then on the past year, it is like 2.47 million tons. And in that, the bio-based formulation shows about 43.7 percentage, like my bio-based non-biodegradable, and bio-based biodegradable formulation constitutes around 56.3 percentage, and it is expected to rise to 5.73 million tons on 29 year. And in that, we expect a huge rise in bio-based biodegradable polymers. Like nowadays, several R&D, several startups, or also the government bodies like DST, SERB is giving a lot of funds to do the test of biodegradation. So definitely all over India and across the globe, we can expect a huge rise in the R&D works of bio-based and biodegradable polymers. And this slide shows the global production capacities of bioplastics in 24 by market segmentation. And in that, these flexible packaging has a major uh, composition in this segment. So majority of the industries and manufacturing units is working on flexible packaging applications, and it is around 6,940 in 10,000 tons. And this slide shows the environmental impact of conventional plastics. So the major thing is landfill accumulation in every places. We can see the plastic bases are just deposited on roadsides, and one of the prime example is while we traveling in train. Even if there is a waste carry bag in the train, but some people are just throwing out the plastic waste in trains and in the stations also. So these all causes the landfill accumulation. So if people are doing it properly, majority of the issues can be resolved. And uh, and and next is marine pollution and greenhouse gas emissions, and the persistence of microplastics in soil. That's also a major problem. And moving to the next slide, it is dealing with microplastics. So the sources from cosmetics, tire and packaging degradation. This all causes serious health concerns and food chain contamination, and it is widespreading across the globe. And the aim of the government and for the various startup industries is like a circular economy for a sustainable future. So that's why the government is still supporting the government is giving a lot of funds for the bioplastic development and for the various startups. So these bioplastic formulations is mainly taken from renewable sources, and therefore the farmers can benefit from that. And also it has a lower carbon footprint, and it shows a better future together. So next slide shows the bioplastic definition. So it is the that it is derived from renewable sources, and it is designed to break down at the end of their life, that thereby reducing environmental impact. So let us take a starch. So it can be taken from tapioca and corn. So this starch formulation is used by various carry bag industries. So it is completely renewable origin, and it costs around per kg like 30 rupees only, and it is very environment friendly, and it is biodegradable option, and it has a very diverse application. And this slide shows the difference between bio-based and biodegradable and compostable things. So it is not same. So bio-based formulation is basically from the made from renewable biological sources. So it is does not indicate whether the material can break down. So example is BioPB and BioPET, it's polyethylene terephthalate. And next is biodegradable classification. So it can be broken down by microorganisms into natural elements. So example is like PV is one example. So it is polyvinyl alcohol. So it is partially biodegradable. Next is and PBAT. So it is another polymer used for carry bag application. So it is also biodegradable, but it is not from biosources. So next is compostable. It is a degradable plastic that breaks down in a composting environment. So under certain conditions like temperature, pressure, and ambient conditions, also RH also factors. Next thing is the classification of bioplastics. So bio-based biodegradable, bio-based non-biodegradable, and fossil-based biodegradable, and fossil-based non-biodegradable. So as I mentioned earlier, the major polymer that is in the carry bag industry is PPET. It is fossil based biodegradable. So if we mix that this PPAD with some bioformulations like vegetable oil and thermoplastic starch formulations, it can be easily degrade within 150 days or 200 days. And next slide shows the feedstocks for bioplastics. So there is a lot of companies in Chennai that delivers starch from biosources like tapioca and corn. And so these major source of supports the various the major formulation of bioplastics. So next is sugar-based feedstocks and agricultural residues, algae, and microorganisms. So several institutions in Kerala is also working on the development of starch from water hyacinth, so not starch, cellulose from water hyacinth. So several work is going on in several institutions in Kerala. And also from seaweed, we can extract several biopolymers. Next slide shows the production routes of bioplastics. So in monomer is then is purified and polymerized to form biopolymers. And in the chemical polymerization routes, the bio-based monomers or the building blocks are obtained from renewable sources. So this bio-P and bio-PET is a prime example. And from the microbial biosynthesis route, the polymers are taken from and purified from the biomass. So this PHBV and other polymers is also an example. And this biocatalytic route is still under R&D is going on. Still, several papers have to be come out from that. And next is the processing methods for bioplastics. So mainly extrusion that I am working on extrusion only. So in that we used several polymers like PLA and PBAT. So in extrusion there is an extrusion machine, then the air cooling or water cooler, then the final pelletizer is there. So extrusion equipment, there is a lot of vendors like Steer, Omega, and Hake is the equipments used for the extrusion. So it costs about nearly 1 crore rupees for that equipment. And next is the injection molding, blow molding, and thermoforming. So in blow molding, for the plastic bottles, this brown film molding is used, and this extrusion is used for majorly from bioplastic industries. So on this slide shows seriously about that extrusion equipment mechanism. In the figure one, we can see a feeder. In that feeder only we are imparting that polymer pellets. And in the figure one itself we can see a lot of temperature zones, and in that from 100 to 200 degrees Celsius can be adjusted in that temperature zones. So it is depends upon the temperature range of the polymer. So if we are using PBAT, it is like 140 degrees Celsius. If we are using PLA, it is 170 degrees Celsius. So we have to identify the melting temperature of the polymer before introducing that pellets into the extrusion machine. So these things have to be considered. And second one is the air or water cooling thing. So if it is like a starch-based formulation, so it will dissolve in the air cooling thing. So sorry, in the water cooling thing. So in that formulation, we have to use the air cooling. So if it is if it is formulation from purely from polymer like PL or PBAT, we can use simply water cooling. So if we use like any bio pigments for giving some colors into the film, we can't use water cooling. So upon the application, we have to choose the air cooling or water cooling. And after and in this stage, that strands is then moved to the pelletizer. So in that, it is cut into several small particles, and that pellets is introduced to the brown film thing to melt it again and to blow into the desired shape. And this slide shows the extruder layout and process overview. In the figure one, we can see the feeder. In that feeder only, as I mentioned earlier, that the polymers or powders, we can use both polymer pellets and powders in that feeder. So it can be worked both. So it is fed into that feeder and it is moved to the extruder. So in that extruder, there is different temperature zones, and after zone 5, it is coming out through a die, and that die is again fed to air cooling or water cooling, and then pelletizer. So in this extruder machine, there is several factors have to be considered. First is the speed of the screw, and it's around 150 rpm to 400 rpm, and the LBD ratio of the feeder, and the barrel temperatures. So if the temperature is high or these pellets is introduced in the feeder for a long time, these polymer pellets will be degraded. So polymer degradation will happen if it is exposed for a longer time. So before feeding our polymers into the feeder, we have to find out the degradation temperature, and the melting temperature of that polymer. Also, it is happen within some minutes. So so longer exposure will leads to the polymer degradation. And and in this slide we can see a video of this extrusion process. The feeder. So that's the thing. So this video shows the extrusion compounding, and this video shows the blonde film compounding. So we can set the temperature and torque values or the RPM. So normally the RPM should be less than 60. So that's the minimum RPM we can fed. So here that pellets have to be disposed, and through the small feeder, it is coming through this area and blown to the shape, and after that it is taken out and into the market. And next slide shows the properties of bioplastics. So mainly the mechanical properties. For polymer films, it have to carry minimum 2 kg of weight. So the expected strength in market is minimum 10 to 12 MPa. So that's a minimum tensile strength. And the another big parameter is that elongation. So how much is the elongation value? That also have to be considered. And next is the thermal properties that I also mentioned earlier, like Tg and Tm and the Td value, and the barrier properties. So it is very important. Like for checking the barrier properties, we will check the OTR and OTR test. That is oxygen transmission test. So that test have to be done. And next is the biodegradability. So if a product have to be sold in the market, so it had to be satisfied some standards for the biodegradation. So how much time it will take to degrade, that parameters have to be considered to sell it in the market. So there is some various certifications and standards for that. And next slide shows the applications of bioplastics, and mainly is the packaging that I mentioned for the carry bags and storage boxes. And second is the agricultural applications, mainly the mulch film for agricultural application. And third one is for the consumer goods and for the textile and fibers. And the advantages of bioplastics is the main benefit is environmental benefit, and various performance advantages, and the economic advantages. And the next slide shows the processing challenges of bioplastics. And the first one is moisture sensitivity. So in that we have to think about the hydrophilicity and hydrophobicity of the polymer. So if we in for that we have to check the water contact angle. So if a film is extracted from the machine, so we can check the water contact angle. So if the angle is less than 90 degree, it is seems to be hydrophilic. If the angle is more than 90 degree, it is hydrophobic. So that thing have to be considered. So that determines the feature of the polymer in it. So if a polymer like PVA is inside it, it will be hydrophilic. Otherwise we have to add some hydrophobic nanofillers to reduce the hydrophilicity of that polymer film. So if you're saying P bad, it is a hydrophobic polymer. So if for that it will be around 120 angle in the angle. Also, there is an equipment to measure the moisture in it, and also the narrow processing window. As I mentioned, is the melting temperature, processing window, and degradation temperature. So, the films or the pellets have to be under very short time in the extruder. So, if it is exposed to more time, it will be degraded, and the limited melt strength is another parameter, and the compatibility with existing equipment. So I would like to introduce about a equipment called Steer. So STER. Steer manufactures the wide amount of things in India. So they have different extruders like Omega and Hake. So we have to identify which equipment is suitable for these bioplastics is the high production cost, limited scale, and feedstock availability. So it is more from the agri sources. This high production cost is will be a problem. So we can sell an LDPE plastic roll for per kg. It will be around 70 to 60 rupees only. And for a bio-based polymer film of 1 kg, it will be more than 140 rupees. So that's a high manufacturing cost will be a problem, and the tight competition with the plastics. And next is slide shows the emerging academic research trends of the bioplastics. So nanocomposite bioplastics. That means we can introduce nanofillers like cellulose nanofiber, cellulose nano so like is it a no like a filler into it, the antibacterial bacterial formulation, the antibacterial property will be increased. And to predict the properties before manufacturing, we can use several AI driven facilities like DN and AN and all. And next slide shows the carbon credits. So hope you all heard about the thing from Anand Ambani group, like Bantara. It is regarding the carbon credits. So carbon credits, it is a financial incentive for reducing greenhouse gas emissions and support a transition to a low carbon sustainable future. So Vantara is a highest carbon credit market in India in future. So people have to buy from them the carbon credits. So it is working in more value. It creates revenue streams and green investment opportunities. and approved agency. So that's major example is Vantara. And this slide shows the several startups in bioplastics in India. So the government itself is funding a lot of money to the startup through CCAMP, KSAP, IAC, and all. So around 25 startups in India is dealing with bioplastic industries. So that shows the major financial outcome in future. And this slide shows the plastic recycling market in India and the problem of plastic waste management. So day by day, the CAGR values increase in day by day, and the up to after 6 years, it is expected to a wide market, and it is due to India is delivering high plastic waste, and for the poor waste management, it is expected to have a good plastic recycling market in India. And this slide was a success story from Kerala. It's from a bioplastic startup called ADS Green Bioproducts based in Wayanad. So in that video, we can see. So he is taking from corn, he is manufacturing starch from corn products, and then he mix that. ഈ ഗ്രാനുൾസ് ആണ് മെൽറ്റ് ആയിട്ട് ക്യാരി ബാഗ്സ് ആയിട്ട് വരുന്നത്. ഇങ്ങനെ ബാഗായിട്ട് വരും, ഇങ്ങനെ ബാഗായിട്ട് വരും. അതായത് ഫസ്റ്റ് നമ്മൾ ഗ്രാനുൾസ് ഇടുന്നു, പിന്നെ ഇത് മെൽറ്റ് ആയി പോവാണ് ചെയ്യുന്നത്. ഇവിടെ ഇതിന്റെ ഉള്ളിൽ കൂടെയാണ് മെൽറ്റ് ആയി. അതെ അതെ, ഹീറ്റിംഗ് ചേമ്പേഴ്സ് ആണ്, മെൽറ്റ് ആയി പോകും. പിന്നെ സെൻട്രലോടെ നമ്മൾ എയർ കൊടുക്കും. അപ്പൊ നമ്മുടെ ബലൂൺ ഒക്കെ വികസിച്ച് വരുന്ന പോലെ ഇതിങ്ങനെ എയർ കൊടുത്തോണ്ടേ ഇരിക്കാം. അപ്പൊ നമ്മുടെ ബലൂൺ ഇങ്ങനെ വലുതായി വരും അല്ലേ? അങ്ങനെ ബലൂൺ വലുതാവുന്ന പോലെ വലുതായിട്ട് ഇങ്ങനെ പോവാണ്. നേരെ പോയിട്ട് റോൾ ആവുകയാണ്. അപ്പൊ നമ്മളിവിടെ കണ്ടിന്യൂസ് പ്രിന്റ് ചെയ്യുന്നുണ്ട്, അതുപോലെ തന്നെ സെൻട്രലൈസ്ഡ് പ്രിന്റ് ചെയ്യുന്നുണ്ട്. പണ്ട് നമുക്ക് കണ്ടിന്യൂസ് പ്രിന്റ് മാത്രമേ ഉണ്ടായിരുന്നു. ഇപ്പൊ നമുക്ക് 4 കളർ വരെ പ്രിന്റ് അടിക്കാൻ പറ്റും. അപ്പൊ ഫസ്റ്റ് നമ്മൾ റോഡ് ചെയ്തിട്ട് റോഡിന് പിന്നെ നമ്മൾ പ്രിന്റിംഗ് മെഷീനിലേക്ക് ഇടുകയാണ്. പ്രിന്റ് അടിച്ചതിന് ശേഷം നെക്സ്റ്റ് സ്റ്റെപ്പ് നമുക്ക് ആവശ്യം ലെങ്ത്തിൽ ഇത് കട്ട് ചെയ്യാൻ. അപ്പൊ കട്ട് ചെയ്യുന്ന പ്രോസസ് ആണ് ഇവിടെ നടക്കുന്നത്. ഇതിനിപ്പോ കവറിന്റെ ഹാൻഡിൽ ഉണ്ടാവില്ല. നോക്കിയാൽ കാണാൻ നമ്മുടെ ചോളം കൊണ്ട് നമ്മുടെ നാട്ടിലൊക്കെ പ്ലാസ്റ്റിക് ഉണ്ട്, അതുപോലെ ഇതിന്റെ ഡ്യൂപ്ലിക്കേറ്റ്സും ഉണ്ട്. അപ്പൊ ചെക്കിങ്ങിന് വരുമ്പോൾ ആൾക്കാർ ഇതെങ്ങനെ ചെക്ക് ചെയ്യുന്നൊരു ഇതാണ് ഞാൻ കാണിച്ചു തരുന്നത്. അതായത് ഇത് നമ്മുടെ ക്യാരി ബാഗാണ്, നമ്മുടെ ചോളം കൊണ്ട് ഉള്ള ബയോ ക്യാരി ബാഗാണ്. നമ്മുടെ ബയോ ക്യാരി ബാഗിന്റെ ഒരു പീസാണ്. അതിനകത്തേക്ക് നമുക്ക് ഡൈക്ലോറോമീഥേൻ ഇടാം. ഇതെന്ന് വെച്ചാൽ നമ്മൾ കൂടുതൽ ഓടകളിലൊക്കെ ഉള്ള മെറ്റീരിയലാണ്. അപ്പൊ നമ്മുടെ ഒരു നമ്മുടെ ചോളം കൊണ്ട് ഉണ്ടാക്കുന്ന ബയോ മണ്ണിൽ 150 ദിവസം കൊണ്ട് ഇട്ടാൽ എന്താണ് സംഭവിക്കുന്നത് ദയവായിട്ട് നമ്മൾ ഇടുന്നു. നമ്മൾ ജസ്റ്റ് ഒന്ന് ഇളക്കി കൊടുത്താൽ ഫുള്ളായിട്ട് അലിഞ്ഞു ചേരും. അതാണ് 150 ദിവസം കൊണ്ട് നമ്മുടെ പ്രൊഡക്റ്റ് മണ്ണിൽ ഇട്ടിട്ടുണ്ടെങ്കിൽ സംഭവിക്കുന്നത്. ഇനി നമുക്ക് ജസ്റ്റ് ഒരു പ്ലാസ്റ്റിക് ഇട്ട് നോക്കി നോക്കാം അല്ലേ. നമ്മൾ നോർമലായിട്ട് തെറ്റിദ്ധരിപ്പിക്കാൻ വേണ്ടിയിട്ട് പ്ലാസ്റ്റിക്കിനകത്ത് നമ്മുടെ നോർമൽ പ്ലാസ്റ്റിക് ആണ്. പ്ലാസ്റ്റിക്കിനകത്ത് ഐ എം നോട്ട് പ്ലാസ്റ്റിക് എന്ന് പറഞ്ഞിട്ട് ഡ്യൂപ്ലിക്കേറ്റ്സ് വരുന്നുണ്ട്. ഇതിപ്പോ തമിഴ്നാട്ടിലുള്ള ഏതൊരു കമ്പനിയാണ് ഇതേ സെയിം പ്രിന്റിംഗ് ഒക്കെ അടിച്ചിട്ട് വരും. പക്ഷേ ഇത് പ്ലാസ്റ്റിക് ആണ്. ഇവിടെ ഇപ്പൊ എത്ര പേർക്ക് തൊഴിൽ കൊടുക്കുന്നുണ്ട്? ഇവിടെ ഇപ്പൊ 9 പേര് നിലവിൽ ചെയ്യുന്നത്. കമ്പനിയുടെ ഉള്ളിൽ 9 പേരുണ്ട്. 10-20ഓളം പേര് ഒന്നുകൂടെ ഞാൻ ചിന്തിച്ചു. അപ്പൊ അങ്ങനത്തെ ഒരു രീതിയിലാണ്. And the next slide shows the major tests in bioplastic manufacturing for the application of carry bags. And the first test is as we all know, the tensile test. The standard is 88 ASTM D882. That's the standard for the tensile test for the thin film testing. And next text is MFI, melt flow index. The standard is ASTM D1238. So in SIPET Kochi, this MFI testing is there. And next is OTR test, oxygen transmission test. So it is a major test for thin film plastic testing. And the standard is ASTM D3985. And the test conditions is very important. And the humidity value is also important. So the temperature, the humidity value will will have the major impact on that. And the expected result for a thin film carry bag should be less than 10 centimeter cube meter square per day. And the next test is water vapor transmission test. So this OTR and WTR value determines the uh, shelf life of our carry bags. And the main principle of OTR test is we have to keep our film in a chamber. So from a low concentration zone to high concentration zone, this oxygen will travel. So that traveling value is taken for the final value. And this slide shows the example of compostable garbage bag. So these garbage bag have taken from a small retail shop. In this figure, we can see some figures. OK Compost, TV Australia. So what is that? So it is a mandatory certifications in India and across the globe for the manufacturing of bioplastic carry bags. And it should be also satisfy these industrial composting standards and home composting standards. That means industrial composting means it should degrade within 6 months, and for the home composting standard, it should degrade within 12 months, within a specific time frames and temperature value. TV Australia is around 10 lakhs. That means the sample have to send to China for that test, so that for that analysis. And this is the mandatory certifications for bioplastic production in India, and mainly this CPCB registration. So we have to obtain the consent to establish and consent to operate certification from CPCB, means Central Pollution Control Board in India, to start the manufacturing plant. Also we have to show the MFI, tensile, OTR, WTR values from enabled approved labs of our thin film to market is expanding to a wider range. So many startups and companies are now coming into this field. So the future is very promising in this field. And thank you all for the time and presence. Thank you. Hello. Hello. Hello.
Yeah, I hear, but the mic was muted. I was talking, but then only I realized. So, thank you, Lince. It was a nice presentation. Obviously, this is eco-friendly. So, before going to the participants, I have one doubt. Can you hear?
Yes, yes, sir. Tell me.
So, there was some classification, no, biodegradable and bio-based biodegradable and bio-based non-biodegradable, like that. One classification was there,
Yes, sir.
right?
Yes, yes.
So that non-biodegradable one, whether it has any advantage over this synthetic plastic, or
Yes, sir. Exactly.
non-biodegradable, what is the advantage?
Sorry, in the case of non-biodegradable bioplastics, So it has more shelf life than the biodegradable plastics. That's the
Yeah.
advantage.
Asking about comparing to the regular plastic that we are using now, synthetic plastic, whether it,
LDP, right?
yeah, 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 whether it
Yeah.
has an advantage or
No, sir. Actually, currently, still R&D work is gone on to improve the properties of bioplastic than LDPE plastics. So still, it is comparable. That is essential.
okay. So I was when I saw this classification, I was wondering why it is like, but obviously after research it will have some improvement or
Yeah.
synthetic. Yeah, yeah,
Yes, sir. Yes.
yeah. So thank you. That was my doubt. So if there is any other participants with doubt, you can ask now.
Yeah.
Uh,
Good morning, Thomas. Can you
Yes, sir.
hear me? Yeah.
Yes, sir. I can hear you.
Yes. Yeah. Well, that was a nice presentation, and you have given enough idea for the researchers to carry on. I have doubts. Only one question: what is the minimum period required for biodegradable plastic? You said now
So
6 months and 12 months. That is the minimum period. Is there any bioplastic which can be degradable below 6 months right now?
yes, sir. Actually, in our formulation, we have found out that it is degrades within 150 days, sir.
Month
One
for one.
fifty days. That is our point of thing right
Okay,
now.
okay. Now, next question is 100% biodegradable plastic is there, or everything will be
No, sir.
biodegradable?
Till
Yeah.
now, there is not 100% biodegradable plastic. So around 89% is degrading.
Okay,
As per the
okay.
results, 89% is the maximum.
Maximum. Yeah.
Yeah, 89%.
So maybe 11% will be remaining.
Yeah, still remaining. So 100% is the achievable target within 2 or 3 years time. So several already work is going on, sir.
Good morning, sir. Can we synthesize bioplastics in the lab? Regular practical.
No, it can be produced because ma'am, actually we
Yeah.
can develop starch from like corn, tapioca. So that biopolymer is can be done. The constituents can be done like
Okay.
starch,
Okay.
seaweed, like that.
Okay. Okay.
okay. So if there is anyone else, you can ask the doubts right now. Or if you are unavailable right now, I can do one thing. I can share his.
Equipment are very, very costly, I think, for this.
Yes, sir. For the
Extruder
equipment is very costly, nearly
and injection
1 crore
molding,
for the extrusion machine. 1 crore.
and injection molding machine also may be costly
Yeah.
because die making is another part involved in that. But thin film,
Like 30 lakhs or 40 lakhs. So for the industrial point of view, it is more than 1 crore. That's the
yeah.
thing.
Because and what from your presentation, what I have seen that most of the testing are done
Yeah.
on thin film.
Yeah. Yeah.
So
Yes, sir.
how that thin film can be produced? What are the machines
Sir,
required?
thin film can be done using the doctor blade techniques, sir.
Pardon? I beg your pardon, sir.
Doctor blade technique. So sir, initially we have to make a polymer film solution. So let's take an example. So if you're taking PVA, so the solvent is DA water. So that polymer powder can be dispersed in DA water. Then after hot plate stirring and magnetic stirring, it can be casted onto a uh, flat surface. So that's called a total blade technique. So I can show you the image. Just wait. Sir, wait.
Visible. Visible. Blade.
Yes, sir. It is the equipment. I can show you. Wait. Yeah, sir, exactly. Sir, is it visible?
Visible. Yeah, visible, sir.
Yeah. Thank you, sir.
Yeah, thank you.
Sir, actually, one more thing for the industrial point of view, this thin film is actually manufactured from that brown film equipment. I can show you that all image also. Sir, the picture number four, sir, four, sir. Image four.
Can you make it bigger?
Yeah,
Blown.
brown film.
Yeah.
Hello, sir. Any more questions?
I think it's over. So I'll do 1 minute. So thank you, Lince. If there is any more doubt, I can share your email ID. They can contact you. So if there is anyone who is not attending and watching this recorded video, so that they can contact you. I think it's okay with you.
Okay, sir. Thank you. Thank you so much.
Okay, so on behalf of CMAT, I would like to thank Dr. Lince Matthews for delivering this session. Truly, it was an engaging one and very, very relevant one. So thank you, Lince. Hope to collaborate with you in future also. Thank you. So with that, we will end this session. In the afternoon session, we have one more session. The resource person is Dr. Javindra Varghese. So see you at 2 o'clock. Thank you. I'll share the feedback form. You can fill it. Thank you.